Okay, let's go ahead and solve this circuit. So first we'll combine it all the way to one equivalent resistance, and then we'll use Ohm's law to come back and we'll solve for each element. So by the end, we'll know the current and potential difference across each of these resistors. All right, so the first thing we're gonna do is we need to start combining stuff. And these are in parallel, but it's in series with another parallel. So we're gonna need to combine these first. And so the equivalent resistance of a parallel is going to be 1 over 600 plus 1 over 400, and then we take the inverse of that. And so we end up getting an equivalent resistance of 240 ohms. So let's redraw. So we have 12 volts coming out. It's going to come across through that 800 ohm. So 12, this one stays the same, that's 800. And now we've combined these, that parallel element. So this one was 560, and these two combined to give me that one, which is 240 ohm. All right, next. So we still have these in parallel, however, this one's here. So we got to do these are in series. So we just add those up. So we get a new one. So we have 800 and then 240 and 560. We add those up and we get another 800. So we combine these right here. So that's 800. So now I have two in parallel. So we do our equivalent resistance for the parallel would be 1 over 800 equals plus 1 over 800. And we take the inverse, so that's 2 over 800, which is 800 over 2. So we get a 400 equivalent resistance. Now we have it all the way down to one resistance. We can figure out the current. So this is going to be 400 ohm. Notice that when we add in parallel, when we add a resistor in parallel, we reduce the resistance. When we add them in series, we increase the resistance, and that's good to know. Okay, so now we have 12 volts coming out. What we want to know is the current. So we start with Ohm's law. The potential difference is just going to be IR. So to get the current, we'll divide the potential difference by the total resistance. So the current is going to be 12 divided by 400. So we get a current coming out of the battery of 0.03 amps. So that's the current here, 0.03 coming out. So now what we do is we just go back. So we go to the next piece and we're going to solve for everything here, and then we'll go back to the next piece and all the way back. Okay, so coming over here, we still have 12 volt battery, and we got 0.03 amps coming out of the battery. And then it splits and it goes to an 800 resistor and an 800 resistor. So since these are the same resistant, the current is going to just split in half. And so we'll get a current of 0.015 amps and 0.015 amps across both of these resistors. So let's call this 1 and 2. Well, actually, it's going to be the same. The potential difference across parallel are equal. We have the same current, so we're going to calculate it though. So the potential difference across 1 and 2 is going to be the current, IR. So the current 0.015 times 800. So we get the potential difference is going to be 12 volt. So that's all of the potential difference of the battery. So these are all in parallel. Remember, in parallel, potential differences are the same. So a 12 volt drop across each of these resistors with a current of 0.15 amps. All right, so now we go, boom, we move over here. So looking at, we've already solved, change this to red. We've already solved this one. That one we know, so that's this one right here. That one we're done with. We figured out the current and the resistance. But now what we're going to do is we're going to use this current. This 240 and 560 made up this one. So we know the current across here is 0.15 amps. I know my work is sloppy, but that's coming across here. Because they're in series, we have the same current in both of these. So now we just need the potential difference. So we'll do the potential difference of the 240 is going to be the current, 0.015 times the resistance, 240. And that gives you a potential difference of 3.6 volts. And then the potential difference across the 560 would be 0.015 times 560. And you get a potential of 8.4 volts. The current across both of them is 0.015 amps. So we have the same current, different potentials. And if we add up these potentials, 3.6 plus 8.4, we get 12 volts, which was our potential across this equivalent resistor. All right, so we solved this one now. That's our 560, so 8.4 volts with 0.15 amps. Now we're going to go and use this one, because this one is made up of these parallel. So we know that the potential difference across here is 3.6 volts. So we have 3.6 volts across the entire thing. And because they're in parallel, they have the same potential. So the potential difference across the 600 is 3.6 volts, and the potential across the 400 is also 3.6 volts. So all we need is the current. So the current is the potential divided by the resistance. So the current for the 600 equals the potential, 3.6, divided by the resistance, so 600. And we get 0.006 amps. And the current, likewise, across the 400 would be 3.6 divided by 400, which gives me 0.0099 amps. And if I add these up, I get my current coming across, which was 0.15. And so we've solved, I know it looks messy, but the basic idea, you put it all together and then you come back and just start solving for everything. Normally when I do these on paper, I draw these big enough so that I can just write everything in instead of writing it like this. But anyway, whatever suits you best.